Multiplication strategy 3, the hardware boxes. In these you use the box layout to multiply those numbers together. You complete the boxes just using basic facts and either extending or opposite extending if it's multiplication or division. This strategy works best when multiplying two numbers that are in the tens or hundreds, or in this example, numbers that have both got tenths or hundredths in them. You earn $23.75 per hour and you work for 3.5 hours. How much should you be paid altogether? It's a great real-world example to check you've been paid the right amount by your employer. So, you've got to decide, are you doing 23.75 lots of 3.5 hours, or is it 3.5 hours lots of 23.75? It's, of course, 3.5 lots of 23.75. So, you're going to lay out your box. In this case, you're going to need 2 columns for 3.5. You're actually going to need 4 rows for 20, 3, 0.7 and 0.05. So we pop all those in. 3 and 0.5, 20, 3, 0.7 and 0.05. Remembering that it's 0.05 and not 0.5. We start doing some multiplication. Obviously 3 20s is 60, nice and easy. This one here is 2 times 5 is 10, so you can obviously write in the 10. And you might think to yourself, oh, I need to remember to come back a decimal point because it's not 5, it's 0.5. So you would indeed bring that decimal point back. But you've also got to remember to extend by a decimal point because it's not times 2, it's times 20. So they actually cancel out. You bring the decimal point back for the 0.5, but you put it back there for the 20. So it actually stays as 10. And if you think about it, what this is really saying is, what is half of 20? And you all know that half of 20 is 10. So that kind of makes some sense just by thinking about it. 3 3s are 9, so that was just a basic fact. 3 5s are 15. And this one, you do need to put a decimal point in and move it because it's not 3 times 5, it's 3 times 0.5. So the decimal point is going to move back 1 space to between the 1 and the 5. 3 7s are 21, and again, decimal point needs to move back 1 place because it's not 21, it's 2.1. 7 5s are 35. This case, you've got to move the decimal point back 1 place for the 0.5, but also another place for the 0.7. They're both dividing by 10. So there's our decimal point. We move it back once and twice, so that one actually becomes 0.35 or 0.35. 5 3s are 15, so we write in our 15. And again, this one, there's no decimal point to worry about up here, but there is decimal here, and it's 1, 2 places back. So we pop our decimal point in, and we move it 2 places back, so it becomes 0.15. And lastly, and this one's quite fun, 5 5s are 25. But in this case, we pop our decimal point in at the end here, and it's got to move back 1 place for the 0.5, but also 2 places for the 0.05. So our decimal point is going to move not once, not twice, but 3 times. And of course we can't move it 3 times at the moment, so we do move it 3 times, but we have to pop in that placeholder to show that we've moved it once to there, and moved it again to get it back there. So it becomes 0.025. It's quite fun, quite complicated. Watch the video again if you're not too sure about how that works. Then it's the final stage, adding it together. I would start by doing all the whole numbers. So we've got 60 and 10 is 70, 79, 80, and 2 is 82. So I would jot down 82 somewhere. Then I would do the tenths. There's no tenths up here. There's 5 tenths there. Another tenth is 6 tenths. 2 more tenths there is 7, 8, 9 tenths. And another tenth there is 10 tenths. And we know that 10 tenths is actually another whole, isn't it? So we just jot down that we've got 1 more whole. And then we look at what else we've got here. We've got 5 hundredths, another 5 hundredths, so that's 10 hundredths. Another 2 hundredths, that's 12 hundredths. And 5 thousandths, believe it or not, that's in the thousandths place. So it was 12 hundredths, 0.12, and 5 little thousandths. So we just pop those at the end. And then we add those 3 together, and you can do that quite simply. 82, 83, 83.125. And that becomes our answer, 83.125. 0.123.